Hi, good evening, everyone. Am I audible?
Yes, ma'am, you are audible.
Okay. Okay, so let's wait 2-3 minutes more. We'll start at 6:05. Okay. Once everyone's joined. Okay, I think enough people have joined. Let's start. So, today is the first revision session for quiz 1. There will be one more session on your regular Saturday one, right? Is it Saturday or on Friday? Any one of those 2 days. I think Friday or Saturday. So, one more
Friday.
session is there. Yeah, so tomorrow.
Friday.
So that session is mainly for your mock and whatever doubts you might have. Today we will be discussing like revision of all 4 weeks. So I have prepared a question set. So we'll solve those questions. They are ranging from every topic that are there in all the first 4 weeks, right? So I think it's better to do questions than go through theory. Whatever doubts you have, we can discuss. Let me share my screen. Also, these are, see, the questions that I'm now going to discuss. These are the types of questions you can expect in quiz 1 also, okay? Because these are mainly PYQs. Other questions are there also, but PYQs are here. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, one second. Okay, let's start with the first question. So this is from week 1, right? So which is the lowest level of abstraction? So what is the answer?
Physical level.
Physical.
Physical, right? Highest level is view level. Application level does not fall within the 3 levels of schema, right? From week 1, you will get questions that are ranging from having 1 to 2 marks, not more than that. This is another one. So suppose a company wants to determine whether the price of the commodity will be an attribute in the shopping database or not. So you have a shopping database for a company and they want to determine whether price of a particular item is should be an attribute in this database or not. So which of the following is correct? Is it a physical level decision, logical level, application level, or view level decision?
Logical level.
Logical level, right? So physical level decision is about how the data is stored, right? What data structures are involved. Logical level is what data is actually stored, the relationship among the data. View level is what subset of data you want the user to see. So here we want to know whether a particular attribute should be there in a database or not. So that is the logical design of the database, right? So it's a logical level decision. For this, we'll get 2 marks. Okay. So now this one. So consider two relations R and S. Okay. So the number of tuples in what is this symbol? Left outer join. So R left outer join S. First of all, what is left outer join? First, we will take, so the table on the left hand side is the left table, this is the right table. So we'll first take whatever rows are matching between them, right? Whatever rows from table R match with rows from table S. So those rows will be there. Other than that, whatever rows are left over in table R will also be added, along with null values for the corresponding S table attributes. So in this particular case, what are the common attributes? B and C, right? So let's go for row 1. This is row 1, row 2, row 3, row 4. So row 1, 1, 2, 3. So 2, 3 is the B and C value. So in table S, can you find a match?
Second and fourth row.
Correct. So let's call this row 5, 6, 7, 8, just so that we don't get confused. So row 6 and row 8. Right. So how many rows we got
correct.
in the matching? 2 rows.
Two rows.
Now check the second row here. So 2, 4, 6. So 4, 6. For 4, 6, do you
No
find a
match.
match? In no match. So 0 rows for this comparison. Then row 3, 7, 3. Are there any matches?
Yeah, row 5.
Row 5. So 1 match. Last row,
No match.
No matches.
3, 4, no match.
No match.
So how many matching rows we got? 2 plus 1, 3.
3.
How many rows are still left which were not matched with anyone in table R? 2 rows. This row and this row. So they will also be added. So a total of how many? 3 plus 2?
Oh,
5 rows. So 5 is the answer. This is clear for everyone? Left outer join?
Yes,
Any doubt?
ma'am.
Ma'am, can you repeat?
See, left outer join means whatever is this table on the left hand side of the symbol, that is your left table. This one is your right table. So you will take every row from left table and match the common attributes with the right table. If you find a match, you will add that row to the final result. Right. So in final result, all the matching rows from both tables will appear. Also, all the leftover rows from your left hand side table for left outer join. So here we found three matching rows, right? One for, so 2 matching rows for this 2, 3 value. 2, 3 value comes here in row 6 and row 8. Again for this value, 7 and 3. This comes here in row 5. So 3 matches, but for these 2 rows, row 2 and row 4, there are no matches. But these 2 will also be included since this is left outer join, right? So total of 5 rows.
Okay, ma'am, got it.
Okay. Should we go to the next one? Any more doubt here?
No, ma'am.
This is solution. Okay. See this. So consider the relation schema company that has 3 attributes: name, area, city, and project has PID, budget, location. So the domain of attributes city and location is same, that is Indian cities. So they have the same domain, but the names are different. So which of the following relational algebra expression would list all cities that are common in company and project? So first option is saying you take a projection of the city attribute from company and a projection of location attribute from project and do a union. So this will not give common cities, right? This will give all cities present in both.
Yes.
Also, this one, second one, see. I take projection of city from company and location from project. If I do a subtraction, what will be left? The cities that are there in company table but not in project table, right? So these are also not common. Third option is saying do a natural join between these two. First of all, is a natural join possible here? Natural join is done based on what?
Column names are same.
So is there any
Common
common attribute between these two?
No.
So this will return 0 rows. Come to the fourth option. It is saying first, let's evaluate this part. So you do a set difference between this and this. So all the cities from company table minus all the cities from location table. So what is left is all the cities that are present in company table but not in location table, right? So this part gives cities in company but not in project. Now if you take this set and take it out from the original company city set, then what will be left? The
Like
cities
intersection.
that are
Common in
intersected.
both.
Correct. So cities that are present in both company and project. So this is just another way of writing that intersection, right? You can always write intersection in terms of set difference.
R minus S.
Correct. So this is the right option. This is clear, everyone?
Ma'am, can you explain why it is 0 for the third option?
Because the attribute names are different, right? Natural join won't be able to pick that.
Okay, I just want to confirm. Okay, thank you.
Okay. Any doubt here? Anyone? All right.
No, ma'am.
Now this. So consider relation G20, country name, foreign minister name, events, date, venue. Now there are three questions. First one is find the name of foreign ministers whose name starts with J and has at least 5 characters. So let's first find that among these SQL queries that are given. So 6 queries are given. You have to find which one is finding the name of foreign minister that starts with J and has at least 5 characters. See option A. Select foreign minister name from G20 where foreign minister name like J and then 4 underscores. So this is exactly 5 characters, right? Not at least. So this is wrong. Option B is saying select foreign minister name from G20 where foreign minister name like J, so starts with J, then 4 more underscores. That means at least 5 letters and percentage. So there can be more than 5. So is this correct?
Yes.
Yes.
Okay. Second question is saying find out the number of events taking place in venue gift city. Okay. So option C, now look at it. Select count events from G20 where venue is gift city. Is this correct? Or option D is saying select count events from G20 where venue gift city group by venue.
Option C
D.
is correct.
Option C is correct. Because there is no need to group by, there is only one venue, right? We are searching for gift city itself. So only finding the count corresponding to that is enough. We just need to find out the number of events taking place. So option C is correct, D is not required. Question 3 is asking find out the venue name and number of events taking place in each venue. So now we are coming to venue name corresponding number of events. So option E is saying select venue, count events from G20 group by venue, and F is saying select venue, count events from G20. Which one is correct?
A. Option is correct.
E is correct because group by venue is required since there are more than one venues, right? And we need both venue name and number of events. So in select statement, both should be there and we'll group by venue. So what is the correct arrangement for question 1? Option B. Question 2, option C. Question 3, option E. You just find the same. So this is option B. Is this clear, everyone?
Clear.
Okay. So from SQL, this type of question might come. Again, okay, this is a good one. So consider these two relations R and S. X is the number of columns and Y is the number of rows of our natural join S. So what is the value of X plus Y? So first of all, tell me, if I do natural join, what will be number of columns here? How many common column names are there?
3.
So how many columns in actual result?
3.
3, because natural join doesn't repeat, right? Now Y is the number of rows. So since there are all 3 of these are common, that means it will take all 3 of them together by default while checking. But see here, the domain of B here and domain of B here is different. So will there be any intersections, any common, any matches?
No.
No.
So Y will be 0, X will be 3.
3.
So X plus Y, 3 is the answer. This is simple, right? Clear, everyone?
Yes,
Yeah.
ma'am.
Okay, now take this. So this is based on delete cascade. This is very important for quiz 1. Okay. Consider the following table which has 4 attributes A, B, C, D, where A is the primary key and C is the foreign key referencing A. So this one inside the table itself is referencing A. Okay. So how many tuples will be left in the table if the tuple 1156 is deleted? So this particular row is deleted. And delete cascade construct is applied over the table. Then how many tuples will be left in the table? So what is delete cascade? Means, see, referential integrity constraint should not be
Broken.
here. That's the main concept. So here if I remove 1156, so this C value is removed, right? And corresponding A value is also removed. So A is the primary key, right? Now in primary key all values are unique. So now the one value is gone. Now
So
in
last
the
2 rows
remaining
need to be
rows,
deleted.
correct. So in remaining rows, we can see last 2 rows are still using the one value, but that is no longer present in the original referenced column, right? So these 2 rows also need to be gone. These are now invalid. Now when I remove this, 6 and 7 are also removed. So any other rows which are using 6 or 7
Third
in
row.
C attribute,
Third.
third row is using 7. So this also has to be removed. So 8 is now removed, but no other row is using 8. So how many rows are remaining? 4 rows. This. This is on
Ma'am,
delete
do we
cascade.
need to, ma'am, do we need to check a foreign key or else a primary key?
See, the primary key value that is removed once, so then that value cannot be used by the foreign key, because then that reference doesn't exist anymore, right? So once I remove this first row 1156 and this value of A 1 is removed, right? So these last 2 rows now cannot be referencing the value 1 because it is now gone from the actual primary key, the referenced key. Understood?
Yeah, ma'am.
So similarly, you have to check until you find that no, all values that are referenced in C right now are still present in A. So at that point, you can stop. This is delete cascade. Is this question clear, everyone?
Ma'am, could you please
Yes.
repeat it once again with the question statement?
Yeah, see.
The relation description about this relation.
See, it is saying
Yeah.
that this table has 4 attributes A, B, C, D, okay, where A is primary key and C is foreign key, referencing A. That means the values that C takes are coming from this key A, right? So C cannot take any value that is not already present in A. Correct? A is the domain of C.
Yes, ma'am.
Yes, ma'am. Yes,
Right.
ma'am.
So now it is saying if I remove 1156 and delete cascade construct is applied, then how many tuples will be left? So first 1156, if you delete, what value of A is now deleted? 1. So A value 1 is no longer in the domain of C, right? 1 is now deleted. So C is still using 1 in these 2 rows. So these are invalid. Now referential integrity constraint is broken here, right? Because this doesn't exist. So these 2 rows also have to be removed. Now when I remove these 2 rows, the values 6 and 7 are also gone from the domain of A. So now C is still using the value 7, which can no longer be referenced since it is deleted. So this row also has to be gone. So now the value of A8 is deleted. But is 8 being used by any C values?
No.
So at this point, the cascading will stop. So how many rows are left in the table still? 1,
4.
2, 3, 4. 4 is the answer.
Ma'am, actually, I'm thinking little bit weird. I don't know. If we are deleting the value primary key, that is 1.
Hmm.
In that case, that value will be null, right? For this reference point. But the keys for 6 and 7 should remain as it is, isn't it so?
See, when you delete one row, right, that row no longer exists in the table. None of those values are there. Right. So
Yes.
1156, when you're deleting, the value 1 is now gone from A's domain. Correct.
Right.
So last two rows have to be deleted since those are still referencing. See, C column is still referencing the value 1, right? In last two rows.
Okay, so I am thinking that that value will become null. So that is
No, it is
not the
not.
case.
It is not null.
That is not
It
the
doesn't
case.
exist. Okay. There is nothing.
Okay.
It is removed entirely.
Okay, so it is not referring, the value is not present. That's why its primary key also get deleted, removed. The primary key which referencing to the that value 1.
See, C is a foreign key. That is referencing the primary key. Okay. But now these two values are foreign key values, right? These two ones
Yes.
in the last row.
Yes.
But these
Hmm.
cannot reference a 1 here because this is deleted now. That means these are invalid values. So both these
Okay.
rows have to be deleted also.
So any value in the relation becomes invalid. So we have to delete the row.
Yeah, the entire row, because then it does not make sense.
Okay. Okay.
Okay.
Thank you.
Then 6 and 7 are deleted similarly. So 7 was still used here. So this row has to be deleted also. But 8 is deleted now. But 8 is not used by any other C value. So everything else is fine.
Yes.
Okay.
Got it, ma'am. Thank you.
Okay. Any other doubt here? Okay. Remember this concept. This is important for quiz 1. Okay. Now see these three relations: orders, product, users. Okay. So what are the keys? In orders table we have order ID, product table we have product ID, users table we have user ID. And what are the foreign keys? Are there any foreign keys? Yes. In orders table, product ID is coming from product table. User ID is coming from user table. So orders table, product ID and user ID are foreign keys. Now question is saying if the relations order, product and user have 10, 6 and 8 rows respectively, what is the maximum number of rows returned by the following query? Okay, but here some part of the query is already cut out, so I am just going to use this much to explain. Okay, select star from orders, right outer join user. So what is the right table here?
Users.
Left table is orders. Okay, so we have to find maximum number of rows returned. So this is right outer join, right? Now, when is the case when maximum number will be returned? What is that case?
When the orders matching column with users, it matches completely.
So, see, I have 10 rows in orders and I have 8 rows in users. So, in the maximum case, can you define what will be the number of rows?
17.
So, what is the explanation?
With one row of user, all 10 orders matching. Because
Correct.
we are doing the outer join. Remaining 7 users also we are displaying in the output.
Right. So, that is the worst case, right? That with one particular row, all rows of orders are matching. And since it is right outer join, so we have to take the remaining rows of users also. So, remaining 7 rows. So, 10 plus 7, 17. Now, what case will be minimum?
Minimum is 8.
When nothing matches, right?
Yeah. And
Not
nothing
even
is
a single row matches, so you take only the 8 rows from users.
Yes.
Correct. So this question is also important for quiz 1. Okay, this works similar way for both left and right outer join, so you can find that.
Excuse me, ma'am.
Ma'am, just one
Yeah.
point here. Even if 8 orders matching with users, all one to
Yeah,
one kind
yeah,
of
that is
matching,
also one. That is also
that
one
also
case.
8 only, minimum
Yeah,
only, right?
yeah.
Excuse me, ma'am. Ma'am, in the same question, actually, I have solved this question in somewhere in PYQs. I have doubt in this question also, because the user ID and the order ID are the primary keys. So, is it possible that the order key have a maximum reference with the user ID?
Means, can you give
Multi
an
means
example what you're
means
saying?
the
All
if we are
three are
taking the
unique,
real
ma'am.
case scenario, in that case, you
Hmm.
know uh, each order ID belongs to a unique customer or unique user ID, and each user ID belongs to
No,
a
not
unique.
necessarily. Not necessarily. A user can place multiple orders, so all of those orders will go back to that same user ID, map
No,
back to
but
that
a
same user.
user ID, but order
Every
ID
See,
must have one
user
user
ID,
ID, right?
every
Order
order
ID.
ID, every order ID must have a corresponding user ID. Okay, but that
Yes.
user ID does not need to be unique in orders table.
Okay.
Okay, that means multiple order IDs, multiple unique order IDs in orders table can be mapped back with the same user ID, because this is user ID is not a key in orders table, right? It's a key in users table. So it's a many to one relation between order ID and user ID. So
So is it
multiple orders.
possible? Yeah, so is it possible to have in orders table multiple value for the user ID?
Yeah, sure.
Its user
See,
ID will
in
be
the
the
maximum
multi-value
case,
variable.
I get it. No,
Hmm.
not multi-valued. Multi-valued is different thing. Multi-valued means in user ID, every cell will contain more than one value. I'm not saying that. I'm saying, let's say there is an order ID 001. Okay, that is coming from user ID 101. There can be another order 002 which is also coming from user ID 101. This is what I'm saying. So in worst case, what happens? All 10 rows, that is all unique 10 order IDs, are coming from the same user. So the same user has placed 10 orders. That's the maximum
Okay.
case.
Okay.
Okay.
Yeah, this point I got. I am thinking about the reverse order.
Reverse order means?
When reverse order means for the order ID 001, we have user ID 101 and 102.
No, no. How can two orders, how can order ID is unique, right? One
But
order is placed by one user, not more than one user. User ID is not a multi-valued attribute. It's a simple attribute.
yeah, that's why I am getting confused in. So
No,
that
no.
concept is not I'm
It's
not
it's
getting clear.
simple. It is
Mhm.
simple. If it was multi-valued, then indicator will be there that it is multi-valued. Okay.
Okay.
In that case, can we say that the 7 users are not having any
Correct.
orders,
So
whereas one
they
user is
haven't placed
having
any.
8 orders?
Yes. So the other users have not placed any orders in
Yeah,
maximum case.
please repeat it, ma'am.
In maximum case, we can say that
Mhm.
there are 8 rows in users table, right? So maximum
Mhm.
case, I'm saying one user has placed all 10 orders and the other 7 users have not placed any order.
Okay. Yeah.
So there are 17 rows in the join. Now minimum case, what happens? One thing you can say is that, okay, none of the users have placed an order, so there are no matches. So only the 8 rows will come from users table. Another case can be that, let's say 8 users have placed 8 distinct orders. So you get 8 matches. So only those are there. In
Yeah.
any case, in any of these two cases, 8 will be the minimum result. Okay.
Yeah. Yeah. Got it, ma'am. Thank you.
Yeah. Clear for everyone? Any other doubt? This question? Okay.
Excuse me, ma'am. Then what will be the output for the
Null.
outer join?
Left outer join. Okay, left outer join, if
Yeah.
you do the same thing here. So if I take order, left outer join users. Okay. So maximum case will be what? 10 rows here, 8 rows here. So one person, so one order in that case, this means what? In the real life scenario, this will mean that if one order finds matches with multiple users, right? That's why we haven't used left outer join in this case, because that is not a meaningful data. One order is placed by one user. But in some case, let's say if somehow user ID is a multi-valued attribute in orders table, okay, that means we can say that one order can be placed by multiple users. Okay, just imagine that scenario. It's not real, but in that case, all 10 rows, okay, out of these 10 rows, one row finds a match with all 8 users, and left 9 rows are there, so they don't find a match with any user, which is not possible. So if there is an order, obviously there has to be a corresponding user, but imaginary case, then also the maximum will be 17 only.
Okay, so that's the question that I'm confused with. So it is not a practical scenario, right?
No, that's why we are not using left outer join, we are using right outer join. Okay.
Ma'am, in the left outer join also, like one order is placed by 8 users, then remaining we should count in left side, right, ma'am? So
In left
remaining
side,
9.
yes. So 17 will be the maximum case, but minimum case will change. Minimum case
No,
will be
maximum case will be 10, right, ma'am? Like one is matching, so and remaining or 9. So 1 plus 9 is 10, right, ma'am?
1 is matching with all 8 rows. So how many rows will be added for this match? 8 different rows will be added, right?
Okay, okay.
So one row here is matching with 8 rows here. So 8 distinct rows are added in the output along with 9 other order rows. So 8 plus 9, 17.
But here every order, because it is mapped to user ID is mapped to user stable user ID, it should match,
Yes.
right?
Exactly. That's why this is not plausible. That's
Not
why we
plausible.
used right outer join here.
Yeah. So it will always be 10.
Yeah. Here, so it has to be 10, right?
10.
At least. That is the minimum case. So minimum case in this point of view is what? If there are no matches, that means you take all 10. Or the other case is that every order is matched with a particular user ID, which is also not possible here because there are 8 users only, 8 unique users.
Right.
Okay. So anyways, minimum will be 10 in this case, but this is not a real scenario, not possible here. There are other questions where we have used left outer join also. Same concept. If you can do right outer join, you can do left outer join. This is clear, everyone? Any other doubt?
No doubt.
Ma'am, what if there is a unique constraint in the place of not null?
Consider all attributes are having not null. In unique constraint, in which attribute you want to place? It will depend on that on which attribute we are placing the unique constraint. Unique is not placed on every attribute, right?
Yes, ma'am. Order ID.
So order ID is already unique in orders table. It is already a key, primary key.
Yes.
So if you make user ID as unique, then it will be different. Yeah.
Ma'am, max number of rows in left outer join.
Max number of, sorry?
Max number of rows in left outer join.
Left outer join will be
in
17.
left outer join,
In left outer join, if you want to perform in this question, it will still remain 17. But it is not a real meaningful data or a meaningful scenario. That's why we use right outer join. But now someone is saying, if I want to place a unique constraint on this user ID, then what is the case? 10 order rows, right? And you have unique constraint placed on user ID. So at max, how many users are there? 8. So at max, how many orders will have user ID values? 8 orders. Other 2 have to be null then. Right? Because there are only 8 user IDs present and 10 orders. So placing unique constraint here would not be plausible as well. If you have 10 users and 10 orders, then you can put unique user ID. Am I making sense?
Yes, that's good.
Okay. Should I go to the next question if this is done?
Yes, ma'am.
Okay. Let's see these two tables. So this first table, students, is having 4 attributes: SID, name, age, GPA. Okay. Second table also has the same attributes, but something is different between these two tables. So it is asking that what query should I execute on this table such that it will result in this table as the output. So now I am not giving you the options yet because you can figure out from here only. See what is different in these two tables. First check the name. Okay, let's check the name.
Name.
So name is it in a particular order?
Yes, ma'am.
It's in ascending order alphabetically, right? So basically I am doing an order by clause on name. If I do that, will I get this result?
Yes, ma'am.
Yes, ma'am.
One more order
But-
required because
yes.
name has same names.
Because name has these two, right? So now how do I place these two? What should be the order for that? So in the resultant
Order
table,
on SID.
correct. So SID here, this is the lesser SID, this is the greater SID, right? That means another second ordering is done based on student ID. So now which one of these options are true?
Third.
Third option. Because first you order by name, and then whatever is not possible to order by name correctly, on those you place the SID order. Like Smith. So you have two same names. So how do you order them? Based on the second SID condition. Right. This one is wrong because it is not in descending order. Okay. This one is simple. Any question?
No, ma'am.
Okay, now see this. This is also, this question has come many times in quiz 1, this type of question. So what is the number of tuples returned by the following relational algebra expression? So first you do a selection. Selection means first I'm filtering out the rows that I want, right? So this is one thing that people still do mistake in these questions, is that they forget what is selection, what is projection. So you cannot relate selection with select statement, right? Select statement relates with projection. Projection picks the attributes, and selection is for you to place the condition, like the where clause. So projection is for attributes, selection is for where clause condition. So select marks greater than 50 from student. So how many rows can I get? This row, no. Greater than 50. This row I can get, this row I can get,
6.
all of these. So 6 rows. So you have to pick the name, project the names. So it is asking how many tuples will be returned. What is the answer?
5.
5, because Rakesh is coming twice, right? And projection does not allow duplicates. So Rakesh will come only once, and then you will have Pranav, Emily, Grace, Lily, these 4. So 5 is the answer. So here the only trick is this thing, that there are 2 Rakesh. This you solve first, then I'll tell. Consider a student relation. Which one is the correct query or queries? This is MSQ. To obtain the last name of students whose age is more than 25. So there are TRC relational algebra expressions given. You tell me which one is correct. Any one of the options, if you can tell me.
Option C.
Third one.
one.
Option C is correct. Why? Because I'm doing projection over selection, which is valid. Selection over projection is not valid, right? So first you select the rows which are age greater than 25, just like the last question, and then you project their last names. That is fine. So this is definitely wrong. Now among these other two, is any one of these correct?
Ma'am, can you again explain the difference between the selection and projection?
Yeah, see, first of all, the valid rule is that you never do selection over projection. That means you never do projection first and then on top of that you do selection. On projection, you also do not use condition, right? Condition is
Okay.
always used on selection. So this is
Okay.
syntactically wrong.
Okay.
So among the other two, which one is correct? There is one correct.
It seems first one.
First
Fourth one. Fourth one.
Last one will be correct, right?
I am asking you. I am not saying anything.
Fourth
So
option.
it is like fourth option is like written a tuple wherein there is some s which belongs to student and it is having an age greater than 25 and last name is equal to.
Fourth option, just the age is given in like not capital A.
That is wrong.
Why? What is the case?
Column name is
So,
different. Case
column name is
sensitive.
here
Okay.
case sensitive, right?
Okay, age.
So if I put it as capital A, will this be correct?
Yes.
Yes.
Is the first option correct?
It is not case sensitive, right? DBMS.
It will depend. Okay, do one thing. Just to avoid the confusion, let's say this is this. Fine. Now, let's say that is not a factor. Is the first option correct? Not talking about fourth one. Is the first one correct or not? First one is what expression? Is it TRC, DRC? What is it?
TRC.
So is this valid TRC?
No, ma'am.
Why not?
There some exist as below student.
So do we write like this? Student T. This T is what? This T here is what? What is it?
Tuple, ma'am.
It's a tuple. So can I write in this syntax in option A that I have written? This syntax is correct. What is wrong here? That's what I'm asking. In option A and option D, what is the difference? What is wrong?
Ma'am, in fourth option, the T should belongs to student.
Come again, sorry.
For option 1, T should be belongs to student.
Yeah, so it is written in this way. Is this correct syntax?
No, it's not a correct syntax.
So option D, is everything correct?
Yes, ma'am.
Yes, option D is correct.
Because we have S belongs to students, right? So here is there any need to write T belongs to students in option D?
No need.
No.
No.
So can I still compare T.lname and S.lname for every tuple?
It will fail. That condition might fail.
This condition will fail, you're saying?
T.lname because that instance of T.lname is not created, no?
Okay. Since there is so much confusion, I'll just show you something. You're not giving me an unanimous result, right?
Yes, ma'am. Actually, I'm confused. No.
So let's just do a little recap.
Yes,
Me
ma'am.
giving the answer will not help. Wait.
We have not reached that week revision.
Yeah, it's fine. Wait. This is in week 4, right? Week
Yes.
4, 4.3, I think. No, 4.2. Relational algebra, I'm pretty sure all of you will be able to do, but TRC, DRC part is a little difficult because a lot of syntax is there. Can you see? Slides?
Yes,
Yes.
ma'am.
Yes.
Yes, ma'am.
Okay, let's do a little recap of what is TRC, what is DRC. So in TRC, I can write like this. So what is it saying? TRC means tuple relational calculus is a non-procedural query language where each query is of this format. So T such that P of T means T is resulting tuples and P of T is the predicate. These are the conditions that we are going to use to fetch the correct set of tuples, right? So like this, when I say P such that there exists S belongs to student and S dot CGPA is greater than 8, P name is equal to S name and P age is equal to S age. This returns the name and age of students with CGPA above 8. So what are the things we are doing? What is P? Set of those tuples which will be returned, right? So for each of those tuples, we are checking that for an instance S of students table, S dot CGPA has to be greater than 8. The P dot name should be same as S dot name because we want to return the name. So whatever we want to return in our query, those attributes must be matched here, right? That is the requirement for TRC. Now relate with this question. What do we need to return? Last name. So I have to match. Am I matching here in option A?
No.
Okay. Still not over. Let's see. Can we find correspondence between these two things? This one and this one. So here also there exists S belongs to student, and so here also there exists S belongs to student. And then we're starting a parenthesis. So will you say that the last option is correct now?
There is missing end.
Okay. So is that, can I not write like this without the and, just if I put a parenthesis? Is that wrong?
Ma'am, I don't think we need to
I guess
write
we
and.
can.
We
Yes.
can write without and.
Yeah, we can skip that. That may the
See
sense
this
is the
one.
same, right?
Here am I using a parenthesis? But is it wrong? No. This question, obtain the first name of students whose age is greater than 21. So you want a set of tuples T such that there exists S belongs to students where S dot age is 21 and T dot F name is equal to S dot F name. Is this wrong?
Not the problem, right?
So can you find correspondence between this query and this query? Are they
Yeah.
similar?
Yes, yes.
Yes,
Yes,
ma'am.
I thought, yeah.
Yes,
This
ma'am.
is correct or not?
Yes, ma'am. Yes.
It's correct. It's correct option.
That's correct.
Then fourth
But
one
this
is correct.
option is not. Right. Here we are not even doing the matching. So what am I fetching? I need the T dot L name. But I need to do this match. See, can you see any expression that is written like this? Wait, something is missing.
Ma'am,
Here
first
there are not
expression
supposed
is
to
same.
be. Wait. Here there's not supposed to be 3 options. In the answer I saw there is only C and D. Okay, let's match this one also. Let's see
Ma'am,
if it is correct.
In the first option, why do we need to match the last name?
That is syntax. Okay, there is ways of writing this. See, 3 different ways you can write the same query. All 3 are valid.
So
T
if
dot
you-
F name student T and T dot age greater than 21. Then T dot F name where T belongs to student. So somewhere you have to state what is T, right? Either you write like this, that T is an instance, a tuple from the student table itself. So you can write student T, or you can write T dot F name where T belongs to student. So T is a tuple belonging to student, or you can write like this, that T such that there exists S belonging to students. So then since you're introducing this S and you're doing the comparisons based on S, so then you have to do this match. If you write in this syntax, any of these 3 syntaxes you can use. Okay, so now check this first solution with option A. Is this correct?
Yes.
Yes, it is correct.
Let's see some more examples also, just to make sure that we are not missing anything. So mainly in most problems you will be getting this type of solution in TRC. Okay, that is T such that. That is the notation we usually use. These 2 notations are not that much used, but there are still questions on them. So all three are valid notations. So options A, C, D all are correct. C is definitely correct. We had confusion between A and D. Both are correct. See, the condition is being matched, right? Here we have introduced extra variable S. So in that case, we have to follow the syntax based on that, where you have to do a matching. With every tuple, you have to do a matching with the current instance. But in option A, we are writing in this other syntax, that t dot fname, where t is a tuple of student table and t dot age is 21, greater than 21. So that same logic is here. So A, C, D all are correct. In TRC, DRC, just check the syntax once. Okay, the day before exam, just go through the syntax once, because this is syntactical errors. Okay, this type of question, only syntactical errors will be mainly there, because obviously if I give something like t dot age is greater than 24, everyone can identify that, right? So that is not the kind of error we'll give. Just go through the syntax
Ma'am,
once for TRC, DRC both.
is it
Yeah.
case sensitive?
No. Case sensitive should not be an issue here. I mean, this in the original solution that I saw, C and D were given as correct options. So obviously age is not an issue. That is fine. Okay. But this one should also be a correct option, because this is another way of writing TRC query. A, C, D all are correct. I'll still ask Piyush sir once about this question, like if this age is given like genuinely, or if it is a typing mistake, what it is. I'll try to ask him once, so he will tell you this question one more time in tomorrow's session. Okay, what is the exact thing going on? But I think all three options are correct, because syntactically they're okay, except for this age thing, right? Is it clear for
That is
everyone?
why I want to ask.
See, I don't think that is an actual issue. I think that is either some typo, because D option is correct in original solution. So either it's
Okay, ma'am.
okay. But still, I'll make sure once. So abuser will take this question tomorrow. I'll tell him. Okay. Other than that, is the logic correct for everyone else? Understood? It is just syntax. Okay. Now this is a very good question on SQL. Okay. So obviously quiz 1 give a lot of weightage to SQL. This question I also discussed in class once. Okay. In week 3 session. So student takes course. 3 tables are there. Student table ID attribute is there, which is the primary key. Takes table also ID, course ID together form the primary key. Course table, course ID forms the primary key. So which of the following returns the ID and name of the students who have taken all courses offered by biology department? So we will go option by option. Our goal is what? That we want ID and name of all students who have taken every course from biology department. So take the first option. Select distinct SID, that is student ID, and S name from student as S. This is the alias. Where not exist. When is not exist true? When is not exist true?
When the subquery returns 0 record.
Correct. So when subquery doesn't return any rows, then not exist is true. So for not exist, null rows means it is true. Right. That means nothing exists. So what is the subquery? There are two parts. It is a set operation we are doing, union. First part is saying select course ID from course where department name is biology. What will this part of the query return?
That means if there are no courses, it will be null. It will return all the course IDs from biology department.
All course IDs from biology, correct. What is this part returning? So this is saying select t dot course ID from takes as t, where SID is equal to TID. That means for a particular student S, right? A particular instance of the table S, or for a particular student's SID. What is this part giving us? All the course IDs that this student has taken.
Yes.
Right, from the course table. So that's why we are doing the ID match here. So we will choose all rows from takes table where the ID is matching for this particular student, and will return the course ID. So all unique course IDs that a particular student has taken. And I'm doing a union of these two. So if I do a union, first of all, union means what? Nothing is reduced from the set, right? Nothing is taken out. So even forget about the second part. Just if the first part returns something, then not exist will become false. And obviously the first part will return something. It will give the course IDs for biology department. So if you union that with null also, then also it returns something. So not exist will be false, right?
Correct.
If not exist is false, then nothing will be returned, because select will only select what? Those distinct student IDs and names for whom the not exist is true. So is this option correct?
No.
No, ma'am.
No, ma'am.
So let's see the second option. Wait. Second option is saying select distinct SID S name from student as X as S where exists. So exist returns true when
At least one record is present.
at least one record is returned. Okay. Again, first part is returning all course IDs from biology. Now we are using except set operation. Except, now this part is returning what? For a particular student, all the course IDs that he has taken. So if I take out this set, let's say the course IDs in biology are bio 101, bio 102, bio 103. Okay. Now if I take out these, let's say a student has taken these courses, CS 101, bio 101, bio 102, bio 103. So for this particular student, what will the inner subquery return?
0 records.
Null.
Null.
Null means exist will be what?
False.
So even though this student has taken all bio courses, his student ID and name will not be shown.
Correct.
So this is wrong. Third option.
Ma'am, please explain it once again. I'm not getting how it will be known.
Yeah, see. Okay. This part is returning what? All biology course ID. Select course ID from course where department name is biology, right? So I am saying let these three be the only courses in biology course or department. Fine. Second part is returning what? Select T dot course ID from takes table as T, where SID is equal to TID. So for a particular student ID, what is this part of the query returning? The different course IDs in which that student is enrolled in or which that student is taking. Right, that's the code, that's the text table, that's what it does. That for a particular student ID, what all courses is he taking? So this part returns that. So I said that for a particular student, let's say this student has taken these four courses, CS 101, Bio 101, Bio 102, Bio 103. So these are returned. Now I'm doing an except clause. Except means set difference, right? So this is the first set, this is the second set. So if I do a difference, what is left now? If I take this out of this, what is left?
CS101. CS101.
This is the first set from which I am taking out this set. Then what is left?
0. Null. Yeah.
Null. Right. That means this student has taken all biology courses. Okay. So that's why this is null. But if null is returned, then exist statement will return what? False. Exist returns true when there is at least one row present. So even though this student has taken all bio courses, his name will be not there in the output, right? Because exist will return false. Understood?
Yes, ma'am.
Yes, ma'am.
So this option is wrong. Now come to third option. Again, this part of the query is same. Okay. So this part is exactly same as the last question. So this part will return null if a student has taken all biology courses. Now outside I have not exists. So not exist will return true if it is null. So if a student has taken biology courses, all biology courses, then this set will be null. Inner subset, subquery will return null. Like I took this example. So for those null values, not exist will return true or false.
True.
So for true value, what will be written? The corresponding student's ID and name. So only which student's ID and name we will get? Who have taken all biology courses. Now they may have taken other courses also along with biology, but they must have taken all biology courses. That's why this is the first set. So is this correct?
Yes.
I think some people have confusion in this, right? Anyone has any confusion? Okay, ask now because this is important question.
Yes, ma'am, please.
Okay,
Just
see.
shortly you can tell.
Yeah, I'll tell you. See, this option, just look carefully. This is the subquery part. Fine. Inside the subquery, there are two sets because we are using a set operation except. This is the first set. Select course ID from course table where department name biology. So this set will return
Yes.
what? All biology course IDs. So I am saying let these be the biology course IDs. Fine.
Yes.
This second set is returning what?
Yeah,
All
CS
the course
that,
IDs, all the
yeah.
course IDs that a particular student ID has taken.
Yeah.
Right. So that is this set, for example.
Yeah, yeah.
Now if I do except clause, then null will be returned because all three are cancelled out by these three.
Yeah.
So when null is returned and not exist is there, then not exist will return true or false. For null, true. Not exist means nothing is there, right? Nothing is existing. So it is true for null values. If one row was also returned, then not exist will be false. It is just the opposite of exists. Okay. So for null, if the subquery returns null, then not exist will become true. If not exist is true, then I can correspondingly return the ID and name of this particular student in my result.
Okay.
That's what I want, right? Students who have taken all biology courses. Here. Anyone has any more doubt this question?
Ma'am, we can use directly, right, ma'am? All by using all.
You can write this query in different ways, okay? But you have to choose from the given options. If you
Yes,
can write this in a more optimized way, very well, do that. Okay, if in OPA exam, do that. Write the most optimized one. But in quiz one, you have to choose from the options given. So you have to be comfortable with this exist, not exist, how it works. Okay.
Yes.
So any more doubt, or should I do the next question?
Just you have to think ulta, no ma'am?
Yeah, exist. See,
second one.
this
it
is
ulta.
this is the trick. Exist will return true if it is not null. Okay, it will return false if it is null, and just the reverse for not exist. It returns true when it is null. It returns false when it is not null. Okay.
And so, depending on true, we are displaying the.
Exactly. So only when where clause is returning true, then only you will return the name and ID of that student in your result. Right. That is where condition is satisfied.
Okay.
Okay. This is also important for quiz one. So in quiz one, obviously, you will not get very basic queries, right? Some SQL queries will be a bit tough. Again, consider two tables, student and course. Now, what are they asking? We have to tell how many rows are returned by this query. Before I do this, you tell me what is the difference between except and except all.
Except all, return duplicate value.
Duplicates also.
Right. If I use except, it will remove all duplicates. But except all will just remove one copy of the duplicates, right? So at every operation of except all, let's say if there are 5 copies of a student ID present, and I say except all, so it will take out only one copy. All the other 4 copies will still be there. So it does not remove duplicates. Okay. So what is the first line of the query? Select ID from student comma course. What is student comma course? What does this mean?
It's a cross join.
Cross
So
product.
how many rows will be there in the course?
Both
In the
are-
cross join? Total number of rows in cross join?
20.
20 rows. Okay. Now in these 20 rows, how many times is each student ID occurring? Each student ID
4
is
times.
occurring how many
4
times?
times.
4 times. right? Because this particular student ID is occurring once for this, once for this, for this, for this, right? Similarly, all the other 4 also. That's how we are getting 20 rows. So each student ID is occurring 4 times. So duplicates, right? 4 duplicates for every student ID. So first part is saying select ID from student comma course. So 20 student IDs will be returned, right? Out of which 5 distinct student IDs are repeated 4 times each. Now except all, select ID from student. So what will this part do? Just this part. What is select ID from student?
It will return 5 records.
It will return these 5 records. So if I do except all, what will be, how many rows will be remaining?
15.
15 rows. So 1 copy is deleted for each of the student IDs, correct? So now how many copies are remaining for each student ID? 3 copies. 3 copies are remaining.
Yes.
Again, one more except all, and same, select student ID, select ID from student. So again, now 5 student IDs are removed. So how many rows are there?
10.
10 rows. How many copies of each ID are there?
2.
2. So what is the question asking? How many rows are returned? So what is the answer? 10 rows.
And
Is this clear?
yeah.
Okay. Yes, this question a lot of people got wrong. Okay, because they didn't know the difference between except all. So always remember these things: union, all, except all. What are the different constraints for union? What are the constraints for union? What is union compatibility? Someone tell me. When can I do union between 2 sets?
All attributes must match.
Okay, anything else? There are 2-3 distinct rules which I'm trying to ask you. So you should know that before the exam. Union compatibility rules. What are they?
The number of columns should be the same.
Number of attributes should be same, right? In both tables. Another thing is what? Domain of attributes. Domain of attributes should match. If any of that is broken, then you cannot perform union between 2 tables. Okay. So before, there are such questions that I have seen that the question, it is given that 2 tables are given, you have to do union. Students have done union and given the result, but union is not even possible in those 2 tables, right? So first always check these union compatibility rules, then you do the union. Because there were trick questions like that where the answer is that zero number of rows are returned. Okay.
Ma'am, in this question, the previous one, ma'am, the order of execution would be from the first statement till the last statement.
First, these 2. Among these 2 sets, except all is performed. Okay. Then whatever is the result of these 2, with that, this except all is performed. Understood?
So basically, we'll be performing that except all 2 times.
Yes, 2 times.
Okay.
One for this set, another for this resultant set, and this third set. Okay. Okay, this is school information system schema. So look at the schema first. So 4 tables are there. No one has any more doubt in this one, right? Previous one? Okay.
There was no point of using just except in the previous question, right?
Sorry?
If we used except rather than except
then
for.
obviously all rows will be gone after the first except only. Because except does not allow duplicates. It will remove all occurrences of the IDs.
Okay.
Ma'am,
but twice.
why we have
So there was no need to use it twice, right?
No. Except if you do only once is enough. Then after once only it will be 0 rows.
Okay, ma'am.
Ma'am, why we have deleted 5, ma'am, rather than we can delete 4, right, ma'am, like from 20?
How many unique student IDs are there?
5 unique students.
So when you do except all, select ID from students, how many IDs are going to be returned? 5 IDs, 5 unique IDs. So except all, 5 unique IDs. So 5 times it will be removed.
Okay.
See, in the beginning, there are 5 unique IDs which are repeated 4 times each because it is a cross join. So after the first except all, there is one occurrence that is removed from every student ID. So now every student ID is occurring 3 times. All 5 student IDs are occurring 3 times. That's why 15 rows are remaining. Again, second except all will remain one occurrence from each student ID, each of the 5. So 5 rows are again removed, 10 rows remaining. Okay, if you are getting confused in this 5 and 4 thing, then you write it while you do the question. Okay, that there are 5 distinct IDs.
Yes.
Okay, now see this. Students table has student ID as a key. First name, last name, email, phone, birth date. Teachers has teacher ID. Again, same things. Enrollment has enrollment ID. Student ID is a foreign key coming from students table. Course ID is a foreign key coming from course table. And enrollment date. Courses table has course ID as primary key. Course name as its own key, right? Course name and credits. And in teachers table, this course ID is also a foreign key coming from courses table. That's the schema. Now question is asking what? Choose the SQL query that will give output first name and email of all teachers whose phone numbers end with 8 and who do not teach history. So what are the 4 different things? We need first name, we need email of teachers whose phone numbers end with 8 and who do not teach history. So where condition will be what? Select statement will have what?
2 tables, teachers and courses.
Teachers and courses. If I take teachers and courses, I can get it. Select statement should have what? Which attributes? What is the question
First
asking?
name. First name.
First name and then
First name,
Email, first name and
First
email.
name and email.
So select is having first name email from teachers. But we also need to check whether they teach history or not. So that course will come from where? Course name,
Courses table.
which is
Yeah.
in courses. So we have to join these 2 tables, right? So now you see the options. First option is saying select teachers.firstname, teachers.email from teachers natural join courses. Can I do natural join between these 2?
Yes, course ID column is
Course ID is
matching.
correct. Where phone like %8 means phone number ends with 8 and course name is not history. Is this correct option?
Yes.
Yes. Let's look at the other ones also if this is an MSQ. Okay. So
Excuse me, ma'am.
Yeah.
Ma'am, difference between natural join and normal join?
Natural join can only happen if there is at least one row in one attribute in common between 2 tables, right? And there you don't have to specify the common attributes. It will or by default take all the attributes that are in common between 2 tables.
Okay, ma'am.
In inner join, you have to specify that which attribute you want to perform the inner join based on.
Okay.
Right. So join teachers join courses on what attribute? So there you do the matching. So here you will do teachers.course ID is equal to courses.course ID.
Okay, ma'am. Thank you.
So option 2, what is wrong here?
They haven't specifically mentioned the common attribute.
Right. So this join will what? No. So this is not. Option 3.
Even,
sorry?
ma'am, even course name not like history is
Yeah.
also wrong.
This is also wrong. Again, select teacher's first name email from teacher's natural join courses where phone number like %dash or underscore, but it should end with 8. So this is wrong. And last one is
Starts with 8.
Starts with 8. So this is wrong. Any doubt here?
Ma'am, in option 2, what is wrong with not like history?
Course name not like history. So that is usually what? String matching. Right.
Ma'am, that
We can use this. We can use this. But here this will stop
Yeah,
here
that
only.
first part
in
is
join.
correct. Yeah, I got that
Not
point.
like is fine. Not like you can use here. Because we check like this, right? If I say that what is the find the name of students whose name starts with J. So you will do what? Name not like J percentage.
Yes,
right.
ma'am.
So not like you can use, that is fine. But this is not okay. Okay, this you will solve first, then I will do. Okay. So two tables are given, employee and manager. It is asking how many tuples will be there as a result of this query. This is the query. Let me hide this. Yeah. So how many rows will be returned? Do it fast. This is very easy question. This inner query is returning what? This part is returning what? Subquery?
Null, ma'am.
So if I do greater than all and all is having a null set, then what happens?
Is it 0, ma'am?
Okay, 0. Everyone agrees? 0 rows should be returned.
No, ma'am. All rows should be written because age is greater than 0, right, ma'am? So the 5
If
rows is written.
see, the rule is that if I have greater than all and all is having a null set, right? That means everything is greater than that set. Okay.
So it will be true for every case, no, ma'am?
So it will be true for every case. So as many rows as in the employee table, all of them will be returned.
5
So
rows.
5 is the answer for this.
Ma'am, can you show the previous question, please? Sixth question that we discussed. The question statement. Okay, so when we say who do not teach history, we can write course name not like history, right?
Yeah, because it is a string. History is a string, right? So we can do string matching.
Okay, ma'am, got it. Okay, thank you.
This question
Excuse
is
me,
similar
ma'am.
for yeah.
Excuse me, ma'am. Yeah, ma'am. This in current question, we are comparing the value with null.
We are not
So-
directly comparing with null. Okay. We are doing what? Employee age is greater than all of null rows. So nothing is returned, right? I am not comparing the age with null value. I am comparing that is the age greater than the age that of all rows that have been returned. But nothing has been returned. So it is not direct null comparison. It is comparing with this all statement. So all is having nothing. That means every age is greater. I cannot do direct comparison with null. That is wrong.
Okay. Yeah.
So 5 is the answer. Any doubt here?
No, ma'am.
Let's do this. So consider following relational schema. Passenger is PID, PName, BID. Pilot is PID, pilot name, flight number. Bookings is booking ID, boarding, destination, flight number, PID, pilot ID. So PID is obviously coming from your passengers table. This is foreign key. Pilot ID is foreign key coming from pilot table. So choose the suitable query that will find the names of all passengers who flew from New York with pilot named James Wan in flight number 3005. So 3 conditions are there. First is boarding should be New York, right? Flew from New York means boarding is New York. Pilot name should be James Wan. Flight number should be 3005. Now look at each of the queries. Okay. Let me start with last query. So first evaluate this expression. Okay. Pilot, natural join, passenger. Can I perform natural join between these two? Pilot and passenger? Is there anything in common?
No, ma'am.
No.
So this is inherently wrong. No need to check this. Again, this one, passenger bookings, can I do natural join?
Yes.
Okay. Now passenger bookings, if I do natural join, in the resultant table, will there be a pilot name attribute?
No, ma'am.
Pilot
It will
name
be
is
ID.
not coming from passenger or bookings. So can
Yes,
I
ma'am, it
check
will be
this
pilot
condition?
then. No, ma'am.
So this is also wrong. Third one, see.
Ma'am,
Pilot bookings. Yeah.
please explain what you just said, ma'am.
See, this one when I do passenger natural joins booking, natural join is possible, right? Because PID is there. But I need to check this condition that pilot name is James Wan. So pilot name is an attribute that comes from pilot table. Will it be present in this join?
No.
So this condition checking is wrong. You cannot find this attribute in this join.
Okay, ma'am.
Now this one, see, pilot bookings. This is also possible. Pilot ID is in common. Now you can check boarding, fine. You can check flight number, fine. You can check pilot name, fine. All three conditions are fine, right? Boarding is coming from booking ID, bookings table. Flight number is coming from bookings table. Pilot name is coming from pilot table, fine. What are you projecting? Pilot name. So which pilot's name will be projected? Will anything be projected? First of all, tell me. Do I need pilot name from this?
No.
No, ma'am.
If I take pilot name, will I be able to perform a natural join between passenger table?
No.
Because pilot name, passenger table, nothing in common. Pilot name is not there in passenger table. So this one is also wrong.
Ma'am, but
There,
finally we need pilot name, right, ma'am? Like we need to
What do we
execute
need?
that
We need
pilot
name of
name,
all
James.
passengers.
Yeah, ma'am. With the pilot name James, right, ma'am?
Pilot name James Van is checked here. The condition is checked here.
Okay.
This is the resultant query from which I'm projecting the pilot name attribute. So why will I project pilot name attribute? I know the pilot name attribute will have only James Van because I'm already selecting those rows only.
Yes,
Right. And again, pilot name is not there in passenger table, so natural join is not possible. So this will give null. This passenger natural join pilot name. First
Yes.
option is doing what? Pilot bookings natural join, fine. Everything else is same up to this point. After I have selected the corresponding rows that I need, where boarding is New York, flight number is 3005, pilot name is James Van. Then I'm projecting the corresponding PIDs. PID is what? Passenger ID. PID is also present in bookings table, so I can project it. Now these passenger IDs, I will find the matching rows in which table? Passenger table. Can I do natural join between these two?
Yes, ma'am. Based on
Because
PID.
PID is there in passenger table. Now from that result, I am just taking the matching rows because it is natural join. So wherever the PIDs match, those passenger rows we will take from passenger table and project their names. So is this correct?
Yes, ma'am.
Because I need names of all passengers. So names of the passengers whose PIDs are matching from this projected PID. Is this clear for everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So this type of longer relational algebra queries, just be careful about the joins and what you're projecting. Or sometimes also to make you get confused, they will put the projection and below that in the subscript they will put these conditions. But projection cannot do any condition checking. That only happens in selection. Okay. So always remember, you cannot do selection over projection, only projection over selection. Okay. Next question we should go.
Yes.
Okay. Now ERD question. So what is the minimum number of tables required to convert this ER diagram into a relational model? First tell me, for each entity do I need a table? Each strong entity?
Yes, ma'am.
So one table here, one table here, one table here. Now check, are there any multi-valued attributes? How are multi-valued attributes
Yeah,
defined?
that phone number.
Phone number.
So here's one, here's one. Multi-valued attributes are taken care of in which way? We have to add an extra table for them.
Yes, ma'am.
So one table has to be added here, one table has to be added here.
I think it's the same domain, right? Can we use same table?
No, they're coming from two different entities, right? Strong entities are different. So for every strong entity multi-valued attribute, you add a separate table.
Ma'am,
Because these
strong.
Yeah, sorry.
How we can tell that it is a strong entity?
Because it is a rectangular box. For a weak entity, it will be a dotted rectangular box like this.
Okay.
So these phone numbers are from teachers table and these are from students table. Okay, we are not keeping them in the same table. So these phone numbers will have a separate table of its own. This phone number will have a separate table of its own. So what type of relationship are, first tell me in this instructor relationship, what is the type of relationship?
Many to one.
Many to one. Many students can be associated with one teacher.
Many to many. This is not one to many. Why are you saying one to many?
It's many to many.
See, one to many is when there is an arrowhead at any one end, right? Here there are no arrowheads. This
Okay,
double
ma'am.
line means total participation. This is not one to many. Okay. That means every student is participating in the instructor relationship, but not every teacher is participating. So this is partial participation, this is total participation. But there are no arrowheads, that means both ends are many to many. Right? Many to many relationship. So for that M is to N mapping, we have to add a separate table.
Yes, ma'am.
So for instructor relation, we need one more table. Again, enrolled relation, what type is it?
Many to many.
What type of participation?
Both are total participation.
Complete participation.
So one more table here. So total how
Ma'am,
many
but
tables?
why do we need one more table for many to many, and why not for one to one, like many to one or anything else?
This thing is, I think it should be discussed in week 4. Was it discussed? See, M to N mapping, you cannot do in one table, right? One student can be taught by multiple teachers, and one teacher can teach multiple students. This M is to N mapping, whenever there is a many to many table, that is both from both ends, many relations can be mapped. Many rows can be mapped to many rows, right? For those relationships, you always need a separate table for the mapping. That for each student ID, which
Course they
teacher ID?
enrolled. Yeah.
Yes.
Which
So here for which roll number of student, which teacher ID are they studying from? So that mapping is done in a separate table. Again, in enrolled, for each roll number, what course IDs are they enrolled in? Or for each course ID, how many roll numbers are enrolled? So there is this mapping, right? M is to N. It is not 1 is to N or N is to 1. That type of mapping, you don't need a separate table, because you can just add one more row to students table and it can be mapped, right? If there is one to many or many to one. But in case of many to many, you always have to take a separate table. If this part is not clear, you can watch the tutorials.
I think we have example in previous questions, ma'am.
Yeah,
Like that why we need a table extra.
Yeah. Also, I think this is discussed in any of the week 4 sessions. You can check that once or check the tutorials once. Okay.
Yes, ma'am. Thank you.
So how many tables in total we need?
7.
7 tables. Let's see. Is this clear, everyone?
Yes, ma'am.
Why?
Ma'am, what about many to one?
Many to one also you don't need. See, whenever there is a one end, right? Whenever there is a one end, so for that you can just add a particular the discerning attribute. Like here, if I said that here this was the one end, that means every student is taught by one teacher exactly, right? Then in students table only you can take the teacher ID, no, and map it like that. You don't need a separate table. So from ERD, what type of question you'll get? 2 distinct type of question. One is this, that is you convert into ER model, what is the minimum number of tables you'll require. So this is like the most that you will get. Okay. In other questions, maybe it will be easier for you because one to many, many to one will be given, or multi-value attributes will be removed. But this is the max that can come. And another thing that you can get is that you will be given the ERD and we'll ask you questions based on it. Like in this particular ERD, if I ask you that is it possible that there is some course in courses entity which does not have any students enrolled in it? Is it possible?
No, ma'am.
No.
Because it is total participation. So this type of statements will be given and you have to tell which one is correct. Okay, I have example of that too. We'll go there. So if this is clear, should we go to the next one?
Yes, ma'am.
Okay. See, this question also a lot of people got wrong just because of carelessness. Okay, this is very easy question. Look, insurance and nominee are 2 different tables. You can see the schema given. Insurance has insurance ID as primary key, policyholder name, age. Okay, but it is specifically written that policyholder name and age cannot be not null and premium also cannot be not null. So none of the attributes in insurance table can have null values. Fine, because primary key already inherently has not null constraint. Again, nominee table, Nominee ID is the primary key, so it cannot be not null, definitely. Nominee name can be not null, it is not specified. Relationship is also can be not null. Insurance ID is a foreign key, right? Foreign key insurance ID references insurance table insurance ID. Okay, where insurance ID is primary key here. So foreign key, insurance ID is a foreign key in nominee table. Can it be null?
No, ma'am.
No, ma'am.
Why not?
It's a primary key.
It's a primary key in insurance table. In nominee table, is it a primary key?
No, ma'am, but it's a foreign key, no?
So foreign key can't have null values?
No. No, ma'am, it has to point to something, no?
Is everyone agreeing with that?
It is a primary key. It is referencing it from the primary key of insurance table, which cannot be null, not null.
But a foreign key can have null values.
Ma'am, in general, it can have null value.
But it cannot match with the primary key in that case, right? If it has a null value. So if someone asks you, can a foreign key have a null value? Yes, possible. There is nothing wrong with that. It can have null value, but it won't be able to trace that value back, right? So here, definitely a null value does not make sense because every nominee is because of some insurance, right? If there is an insurance only, then there is a nominee. So the nominee must have some insurance ID. Okay, but nothing is specified like that. So here, what is specified that in insurance table, all the attributes should be null, not null, and in nominee table, only nominee ID should be not null. That is given. Okay. Now these are the two tables. If you do this, delete from insurance where insurance ID is INS001, what will be the value of X if X represents total number of rows in insurance and nominee table counted together? So first let's delete, right, INS001 from insurance. So this row is removed, correct? If this is removed, what else should be removed?
Ma'am, all the ones that are referring to it.
So wherever this foreign key is referring here, right? So if INS001 is now not in that domain, so can this row exist, the first row?
First
No,
row can't.
So this has to be removed. This is again on delete cascade, right? So on delete cascade questions can come in the same table, can come in multiple tables. Now, anything else that needs to be removed?
No, ma'am.
No,
How many rows are left in both tables together?
3 in above and 2 below. 5.
5.
Five
The
rows.
answer to this is 5. 5 is the answer.
Ma'am, this is the
Ma'am,
reason
don't
why.
we multiply, ma'am?
Come again?
If we take it as a cross join, and don't we need to multiply them?
I'm not taking as a cross join.
But counted together, okay.
Counted together means just count. Okay. Not cross join. So after the deletions are done, then how many rows are left in insurance, how many are left in nominee, then just add them. Okay. That's why X is defined. Now in the same question, part question is, if I insert these statements in this particular sequence, then what will be the output of the below query? So first let's do the insertion. Okay. Now see, this is a new question. So whatever changes we made here does not exist. Fine. These are the original tables. On these tables, now you do these insert statements. So can I, in insurance table, insert these 4 values in a tuple, in a new tuple? INS005, Rakesh, 24, 7000. Is it possible?
Yes.
Yes, ma'am.
It is not violating the primary key constraint, right? Rakesh, so not null constraint is also satisfied, and whatever is here, right? So 1 row is added in insurance. In nominee, add NM004, Sonu, Sun, INS005. Can I add that? Is it violating
Yes.
anything?
No.
So NM004 and whatever values are there. Next is again you insert in nominee NM004, Suman, wife, INS004. Is this possible?
ID is repeating.
No,
ID is
nominee.
repeating. So primary key cannot have duplicate values. So this insertion will not work. The next insertion, will it work?
No, ma'am.
No, it's the same.
Again,
No,
same
ma'am.
thing.
No,
So
ma'am.
this also will not work. Last one is saying insert into nominee, but only for these two attributes: nominee ID, insurance ID. Insert NM00 010 and this INS
Yes.
005. This will have null. This will have null. So is this possible?
No,
Yes,
There
ma'am.
ma'am.
is no constraint on nominee name and relationship.
Null is not
Right.
allowed.
So
No.
nominee ID is unique and null values are allowed in nominee table. Right. In nominee table, for nominee name and relationship, not null is not specified. Correct. So I can have null values. Yes or no?
Yes.
Yes.
Okay,
Yes.
ma'am.
Okay. So now this is my new two tables. Now what is the query? Select star from nominee. Okay. So see, this is the new nominee. Select star means select everything. So which one of the options is matching among these three?
Last one.
Null,
Last
null,
option.
This correct. This is correct, right? Will there be any issue because there are two INS 005 here?
No problem.
No problem. It is a foreign key. Okay. This question is clear, right, everyone?
Ma'am, can you explain the last option, please?
See, this is the same nominee table that I created here, right, after the insertion. These two rows are inserted. Initially, these three were there. Then this Sonu, this insertion worked because NM004 was not a primary key yet. Once this is entered, then you cannot enter more rows having the same primary key. That is a violation, right? But you can again add the last row, this one, because nominee ID is now NM010, which is a new nominee ID. So it can be a primary key. So total of 5 rows are now there in nominee table. So the select query is select star from nominee. So it will return all 5 rows.
And nominee name and relationship can be null, right?
Right, because here in the question it is not specified. Nominee name is not given as not null, relationship also.
Okay, ma'am. Okay, got it.
Everyone clear?
Yes, ma'am.
Now this. So 3 relations are there. One is drivers, one is brands, one is designations. Okay. So drivers relation has driver ID, driver name. Brand ID is coming from brands table, where brand ID is the primary key. So this is foreign key. Again, designation ID is also foreign key coming from designations table. Now what will be the result of this query? This looks big, okay, but it's very easy. Intersect means obviously set operation is there. So this is the first set. This is the second set. Let's do what is the first set doing. Select driver name from drivers D, natural join, designations T. First C. Is natural join possible between drivers and designation?
Yeah, and designation ID.
Yes, ma'am.
Yes, ma'am.
Where, so we have to select what? The driver name, just the name. Where T dot salary is greater than, now do the subquery. All. What is this part returning? So inside the subquery, now let's do select salary from designations T, brands B, drivers T. So all 3 are joined, right? Joined in what join?
Equijoin.
Cross join also you can say, right? Designation brands first, and then with the result do another join, cross join with drivers. So all 3 tables are now joined together. So you have to select the salary where designation ID is matching with driver ID, driver designation ID. So T dot designation ID is equal to D dot designation ID and B dot brand ID is equal to D dot brand ID. So you select only those rows where these conditions are valid. So among all rows, now all 3 tables are joined. So among all possible rows, you have to find those rows where the designation ID is match, brand ID is match, and brand name is Mercedes. So what is the inner query returning? Just the inner query.
Salary of all the drivers who drive Mercedes.
Salary of all drivers who drive for Mercedes. Can I say that?
Yeah.
Yes.
Now, from this set, What am I selecting? The driver name whose salary is greater than all Mercedes drivers' salary.
Yes, ma'am.
Yes, ma'am.
So the first set is what? Wait.
All drivers having salary greater than those driving Mercedes.
Names of all drivers having salary greater than
All the Mercedes drivers.
all Mercedes drivers. Okay. This is first set. Now second set is doing what? Again, let's start from the inner query. Select salary.
So
Again, join all
same
three
as
tables.
above, Ferrari driver.
Same. So now this is the
Less
salary
than
of,
the salary
yes,
of Ferrari
less.
driver.
So this is what you are finding the names of all drivers having salary
Less
less
than
than Ferrari drivers.
Ferrari driver.
Okay. And intersect. Now between these two sets, if I do an intersection, what will be the result?
Names of drivers who have salary less than Ferrari but greater than Mercedes.
Correct.
Yes.
So now just find which option. First option.
First option.
Okay, this was easy. See, it just looks like a big query, but it is very easy. Okay, because you are just, see, since you are joining all three tables, so for that, this is the main part, that you have to match the correct attributes, right? The designation IDs should match, the brand IDs should match, and then you place the brand name, which is your actual condition. So we could have done this using an inner join also. So you join two tables first using the designation ID, and then you join the third table using the brand ID or something like that you can do. Okay. Or natural join of two tables at once. Different ways you can join. Is this one clear, everyone? This is a PYQ. Okay. Yeah, this is the explanation. This division operator, right? This is also another important one. So what will be returned? Which item names will be returned by the operation food items divide item info? Which item names will be returned? So operation is food items divide item info. Item info contains what? Amul 5, Nestle 4. So only those items will be returned which have both combinations present, right? So for chocolate, you can find Amul 5 is there. For chocolate, can we also find Nestle 4 combination?
Yes.
Yes.
So will chocolate be in the result?
Yes.
Yes. For
Yes.
ice cream, I can find Nestle 4. Can I find Amul 5
No.
for ice cream?
No.
So ice cream can't be there. For cake, I can find Amul 5. Can I find Nestle 4?
Yes.
Yes.
Cake will be there. For candy, Amul 5 is
Yes.
there, but Nestle 4 is
Nestle
not
is
there.
also
Nestle
there.
3
Okay,
is
no.
3. So which items will be there in result? Chocolate and
Chocolate
cake.
and cake.
Option D. For division operator, only this type of question will come. So there is, in the slides, you can see that there is this relational algebra operation given corresponding to that division operation, right? That what is the corresponding relational algebra equivalent. So that part, if you do not understand, since it's a bit of a bigger expression, if anyone has doubt understanding that expression, you can check out the last terms week 4 session that I took. So there I have broken down that particular expression and showed that how it is being derived. Okay, but that derivation will not come in exam, just so you understand. So that, see, sometimes it is questions like this have come, that which of the following relational algebra expression is equivalent to division operator. So then you have to identify the correct expression. Okay, so just look over the expression once so that you can identify if any such question comes. Okay, did you understand what I said?
Yes, ma'am.
Okay, this question is clear, right?
Yes, ma'am.
Okay, this, consider a relational schema: instructor, ID, name, department name, salary. To change the data type of ID, which of the following categories of SQL command is used? If I want to change data type of a particular attribute.
DDL.
DDL.
last option.
Can anyone tell me what command?
Alter.
Alter table, correct. So to change the data type of already created database, you use alter table, which is a data definition language, right? Okay, see, this is 2 marks is very easy for this question. Okay, two more, these two tables, instructor and department. Okay. Question is, which of the following queries will find out the names of all instructors whose department is finance or whose department is in Watson or Taylor building? Okay. First one, let's see. Select name from instructor I, department D, where department name, yeah, they're joining based on department name, that is fine. And I dot department name is equal to finance or building in Watson Taylor. Is it correct?
Yes, ma'am.
Yes.
Looks correct only. See the next one. Select name from instructor I, department D, where department name is finance or building in Watson Taylor. Is this correct?
No, because where ID is not there.
Because we are
Joining is
not
not
doing the
joining
join
is not
properly.
It's not.
Right. It's not a proper join. Cross join will give many duplicate results. Okay. It can still do this. Okay. The operation will perform, but the result will not be correct. Okay. Option 3. Select name
It is given and instead of R. We are expecting
and
R.
given. Right. So we need or here. This is wrong. Last one.
Yes.
Natural join possible, where department name finance or building in Watson Taylor. This is also correct. So A and D are correct here. This, do I need to explain or everyone understood?
Understood, ma'am.
Okay. D is correct, A is correct. Yeah. Okay, now this is also important. Check statement. Okay. So create table cars where car ID, car name, car color, year of purchase, and primary key is car ID. But there is the check statement which says that year of purchase should be in among these 4 years. So check does what? It will check the year of purchase value for every tuple. So following these two tuples are already inserted. So see, for these two tuples, year of purchase value is valid or not?
Yes.
Yes,
Yes,
that's
yes.
why
Yes,
that's why they were possible to insert, right? Now you have to find out which among these will cause an integrity violation. So when I do the first, this one, insert into cars, C3 McLaren Orange 2003. So can I insert?
Yes,
Will there
ma'am.
be any violation?
Yes, ma'am.
I can insert. Okay. So
Fourth
this will
option.
not cause, right? Because this question is asking which will cause. So this is not an answer. Second is saying insert into cars C2 Alpine Green 2001. Will this cause an integrity constraint?
No,
Yes.
Violation?
no one.
Why? Card ID is primary key. Can you
C2.
insert C2 again?
Oh, okay. Fine.
C2 is
Yes.
already a primary key, right? So this is one of the answers. C2 is causing primary key violation, right? This one, C4 Williams Black 2002. Will it cause any violation?
No, ma'am.
No, ma'am.
Year is also in the range of check, right? And new primary key C4. So this will not cause any violation. Last one, C5
Yes, ma'am.
Alpha Tower
Yes.
Blue 2002.
Yes. Year
So
of purchase.
2005 is not there, right? So it cannot be inserted. So these B and D are wrong. Clear? Any doubt?
No, ma'am.
Okay. This is the last question. So this is the other type of question I said can come from this ERD. So company, items, customer, right? First tell me company and items, what type of relationship?
Ma'am,
One
one
to
to
many.
many.
One to many, right? What type of participation?
Total participation.
Both are total.
Both sides total. Again, what type of relation in customer items? This orders relationship?
Many to many.
Yes.
Many to many. Participation from customer side?
Total
Total.
participation.
Total. Item side is partial.
Partial.
What is the multivalued attribute here?
Phone number.
Phone number from customer. Okay, now look at these statements. Which one is correct? First is saying there might exist a company that has not produced any items. So can there be a company which has not produced any items?
No, ma'am. Total
No.
participation.
Total participation.
No.
Every company must participate in this relationship. So first one is wrong. Second is saying there might exist an item that has not been ordered by any customer.
True.
So items table has partial participation. So
Yes.
some items are there which are not ordered by any customer. This is correct. A company can produce at most one item. Is that true?
No.
Yes.
This is the side, right? This is the
Okay.
side. So company 2 items. So company can produce more than one item. This is the many side.
Yes, ma'am. One company can produce many items.
Yes. A customer can buy more than one item.
Yes.
So this is many to many. Customer can buy as many items as they want. Right. So this is wrong. This one is correct. So B and D are correct. Any doubt in this? Can there be a customer who hasn't ordered anything?
No, ma'am, because total participation from customer side.
Right. Right. How many tables will we need to reduce this? Minimum tables?
Ma'am, 5, ma'am. One for company, one for items, one for customer, one for phone number, and one for that productions.
Orders.
Okay. No, ma'am,
Producers
order.
is many to one too many, right?
Oh,
Orders is
sorry.
many to many.
Yes, sorry, my mistake, ma'am.
Okay.
Extra.
5 tables. Okay, these are all the questions I had. So are all of these
It's
clear?
right, ma'am. Three
Yeah.
entities, three
entities.
tables,
3 tables.
and that produces that also requires one table.
No, producers is one too many, right? There is a one side, there is a many side. Only many to many requires a separate table. So orders.
Okay.
Orders will
Okay.
require a separate table. And phone number is a multivalued attribute. So a different table for that.
Okay, correct. Yeah, thank you.
So all questions that we discussed are clear for everyone, right? Any doubt anyone has?
Ma'am, will it be uploaded in supplementary content after?
If you want, then I can give this to you. Okay, on Discord
Yes,
I can
ma'am.
upload.
Ma'am, we
Please,
require.
ma'am, yeah.
It will be helpful if you upload it.
Okay, I'll upload on Discord. Okay, so after this class I'll do, you can download it.
Thank you then. This is recorded, right? We can access.
Yeah,
the-
yeah, it is
Because I
recorded.
missed two question in between. Thank you.
It is recorded in our channel. Okay.
Even
Now
in
next class.
here
yes.
also it can be shared. I mean, no.
In Google
Chat
Meet it is not. No, in chat I don't think. In Google Meet we can share. In Zoom we can. Let me try it.
Ma'am, at least you can tell the year, ma'am.
I can tell what?
The year of this paper.
Oh, year. No. This is not from one paper. This is from multiple papers I've taken.
Okay, ma'am, it's better you share on Discourse.
Yeah,
ma'am, then.
I'll share on Discourse right now.
Or else
Okay.
if some student doesn't have the discourse link, then we can you can upload in this with dashboard, whatever we are having.
Supplementary contents. Okay, I'll ask you sir to upload then, but I'll do on Discourse also. Okay, so both I'll try to do. If I cannot do on supplementary contents, then in the calendar, the link for this session where it is there, right? There I will upload the PDF.
Yes, ma'am. Yes.
Okay.
Sounds good.
Excuse me, ma'am.
Yeah.
Ma'am, I have two doubts. Is it possible me to share the screen?
Yeah, sure. Wait, I'll stop sharing. 1 second. Yeah, others, if you don't have a doubt, you can leave because next session is all about doubts and mock only. So there you can ask everything else.
Ma'am, I just want to ask, do we get questions related to DRC?
Yeah, definitely. DRC both you'll get.
Ma'am, is my
Possible
screen
for you
visible?
to explain that DRC once? Or if you
DRC.
can tell me the session. Yeah, I just get confused when it comes to
Yeah, you see,
DRC.
DRC will be there in any, I think, week for session 1 or session 2. One of them DRC is discussed. Okay. But if you
Which
want,
is
I can
now?
just
Ma'am,
in
right now
this
if you
term
can do.
only.
Right now if it's possible for
Yeah,
you.
Okay, I'll show you once the DRC query. Okay. Yeah, who is sharing? I can't see.
Yes, ma'am.
Huh.
Is my screen visible, ma'am?
Yeah.
Just a minute. Yeah, ma'am, this is doubt. Are you able to see my doubt?
Mhm.
Yeah.
How many rows will be returned by the output of following query? So players left outer join points on player ID. Okay. So left outer join players is the left table, right? So
Yes.
how many matches are there? First, let's find out. So player ID. So take the first row from left table, right? Can you find a match in player ID? Yes.
Yes.
First row is matching. Second row, can you find a match? Yes. Third
Yes.
row also, fourth row also. But
Yes.
for fifth and sixth rows, there are no matching. Right. But what type of join is it? Left outer join. So those two rows are also included in the result. Right? So
Okay.
all six
Okay.
rows are there. Now J%. So how many people with name starting with J? 2 people.
John and Joseph. Jake. 3.
So 2 is the answer.
Who is wrong,
Jake
ma'am?
is there
No,
also.
Jake is also there.
Yeah, Jake is
Jake,
also there.
John,
But
and
3 people.
Joseph.
3 people.
Jake,
Yeah.
John, and Jason. Okay.
Yeah.
Okay. Because I got it wrong. I have answered 2 and one more.
Since all rows are coming from left table, no?
Just a minute, ma'am. And this one.
Just zoom in a bit.
The last one. Menu to many. It says menu to 1.
In a typical design, what is the relationship between student and enrollment table?
Table. Yeah, let me show you the question.
Yeah,
This
this
is the
is many to
question.
one only, right?
I didn't get it, ma'am.
See, what is the typical meaning of enrollment? One student can enroll to many courses, right?
So it should be one.
Okay. Wait. Let me read once.
Many, no, ma'am.
Give me the
Many to
question
many.
once. In the enrollment table, which one is the typical way to handle primary key? This one you're asking.
No. This one. Second one. In a typical design, what is the relationship between the student table
Student and
and the
enrollment. And
enrollment
what is
table?
the comprehension passage?
This is the passage.
A startup company is building an online learning platform that hosts courses on various subjects. In this platform, student can enroll in multiple courses, and each course can be taught by one or more instructors. Okay, the company wants to design the database schema. So if I take student and enrollment, so student can enroll in multiple courses. So for one student, there are multiple enrollment IDs, right? For
For a
different
student,
courses.
there will be the yeah.
From one student, multiple enrollments can happen. Again, in one course, multiple students can handle, right? So
Yes.
if I take
Yes.
student and course, that's a many-to-many relation. A student can take multiple courses. A course can be taken by multiple students, but enrollment it is asking. So what is enrollment? A student can enroll into a student can have multiple enrollments, but an enrollment ID is unique, right? Every
Unique for a
enrollment
student.
ID is
Yes.
unique. So it is many to one.
Yes, ma'am. Now got it. Yeah, just a minute, ma'am. I think I have one more doubt. It's done. This is also done in the question. Yeah, this is also done. Yeah, this is yes, ma'am. That's all from my side. Thank you, ma'am.
Yeah. Okay. So someone wanted that DRC part, right?
Yes, ma'am.
Okay. Wait, let me share. Can you see my screen?
Yes, ma'am.
Wait. This is visible, the lecture 4.2 slides?
No, the previous PDF is open.
Okay, wait, let me reshare. No?
Yes, ma'am.
Okay.
Shweta, please mute yourself.
Huh? Sorry?
No, somebody's mic was on.
Okay. See, DRC is just another way of writing. So these three things have equivalent power, right? Relational algebra and TRC and DRC. So whatever you can write in relational algebra, you can write in TRC, DRC, and vice versa. Okay. So in TRC and DRC, the only difference is in syntax, right? So equivalence of, okay, no, this part we don't need. Domain relational calculus. See, TRC query is of this expression. Okay. So x1, x2, xn, these are all domain variables. So in TRC, we focus on tuples, right? We write T such that, where T is the set of tuples. In DRC, we focus in domain relational calculus. So domains. X1, x2, xn are all domains. These are domain variables. P is what? It's a formula. That is the predicate. That same predicate logic. Now, let's take an example, then you'll understand. Examples are there, I think. Not these. I wanted the example slides. Wait. There were some slides where just the examples were given. Were that to 4.3? Let me check once. Just showing syntax won't make it clear. No, this is ER model. There are no slides with DRC examples. Not possible.
We just have that example of division.
No. Query examples, not like that.
Yeah, I don't think so. No.
But I took one class where I used a lot of slides to take examples. Wait. Without the example, I can't. No, in any of the slides here, that is not given. Wait, let me check one thing. I think I have the slides. Week 4. I shared those slides on Discourse also. Why it is not here? Okay, see, one thing I can help with right now.
Is it possible for you to tell me the session that you took?
That's what I'm trying to find. Wait. DRC, right? So last term to last term. Last to last term. Okay, so I think it was September term 2024. Okay. In that session, you can find first session of this one, week 4. First session, week 4, 2024, September term. Okay, that session is very good. There TRC, DRC both are discussed with examples.
Okay, ma'am, you have taken that session?
Yeah, I've taken that. So if you still have any doubts in that, please ask me on Discourse, okay?
Okay, ma'am, sure. I'll go through that, ma'am.
Okay. All right, yeah. Thanks, everyone. Thanks for joining. Best of luck for your exam.
Thank you so much, ma'am. Thank you. Thanks a lot.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Please join tomorrow's session also.
Ma'am, tomorrow, day after tomorrow?
Tomorrow, I think. Check in the calendar once. I think it's tomorrow.
Tomorrow only.
Yeah, tomorrow.
Okay, ma'am. Thank you.